Hi, in this video lecture, we're going to solve a very commonly asked interview questions based on strings topic, and that is reversing the individual words of a string. For example, here I do have a string with multiple words, and the data is like programming with Sikandar. I need to take the first word, and then I need to print this first word in the reverse order, take the second word, print in reverse order, take the third word, print in the reverse order. This particular problem can be solved in multiple ways, and one of the ways is using a data structure called a stack. And the logic to solve this particular problem is you start scanning the characters from the first character, and if the character is not a space, you try to put that into a stack. Like you try to put P into the stack, and then the next what happens is the R. And since you're putting in a stack, R will be on top of P. Then the same way, O will go in the stack. Then G will go in the stack. Then R goes in the stack. Then A goes in the stack. Then M goes in the stack. Then one more M also goes in the stack. Then I goes in the stack, right? And then N goes in the stack. And then G goes in the stack. After that, when I encounter a space, you need to pop out all the elements from the stack and then print that on the screen. So what element will be popped out first? First, G will be popped out. You need to print G onto the screen. You need to pop out G and print G onto the screen. And then you need to pop out this N and then print N onto the screen. And then I you need to pop out and then print that I onto the screen. Then same way M. Okay, then M, A, R, G, O, R, P. So you pop out all the element from the stack. Okay, once you reach to the point where the stack is empty, then you continue forward with the second word. Like for example, you have W, you try to put W onto the stack, then you try to put I onto the stack, then you try to put T onto the stack, then you try to put H onto the stack. Okay, after that, again, when you encounter a space, you need to pop out all the elements with H, T, I, W, right? So this way we have to repeat for all the characters in a string. Okay, so if you want to use a stack in C++, C++ provides you a built-in data structure called a stack, which is a part of STL. We'll be using that. And this particular data, I would like to capture this into a variable out here. I will mention the variable name is data, and I'll be using the data type of this is string data type. Okay, C++ provides me a string data type, so I don't need to bother about the size of an array. And if you want, you can also read the data from the user with the help of C. Next, I would like to create a stack, which is again coming from std namespace. And I would like to create a stack where every element is a character. Okay. And I'll name the name of the stack as STK here. STK is the name of the stack object, and this stack is the class name or the built-in class, which is a part of STL. Okay. So here I need to traverse every character. If you want to traverse every character of the string, I can use a traditional for loop where I can use indexing and I can say I not equal to data size and then I plus plus. This is one of the ways what I can do it. The other way what I can do out here is I can also use a for each loop. So I can just use for character C colon data. So this will take care of traversing all the characters of a string. It will do the similar job of this, but here I will give me the index data of I will give me the character, whereas here C will basically give me the character. First iteration you give me P, then R, then O, that particular fashion. Okay. Now I need to check out if it is space or if it is not a space. If it is not a space, so how do we check if it is not a space? I will take the help of eSpace function. eSpace function is a part of ctype.h, and that returns me a non-zero value if it is a space and zero if it is false. And I would like to check for not space. So if I want to check for not space, I can just apply the not symbol out here, the logical not. And if it is not a space, I would like to put that into a stack. And then there is a push method in a stack which will accept the character what you want to insert or the element what you want to insert and then puts it on top of the stack. Okay. But what happens if it is a space? If it is a space, I would like to pop out all the elements, okay, as long as there are elements in the stack. So I need to repeat this operation, popping it out till there are some elements, or you can say it as long as the stack is not empty. I'll just try to check out. How do I check out the stack is empty or not? It provides me a method called as empty. This particular function returns true if the stack is empty, but I would like to repeat the loop as long as this returns me false. Okay. When it returns true, I'd like to stop the loop. Okay. So here I'd like to pop the element and then print it. But remember, the pop function in the stack does not return me the character which is deleted. So you can just return type of pop is void. So before you remove the element, you need to get the top element and you need to print that. How do I get the top element from the stack? So it provides me a method called as stop, and you can just observe if you're working with a stack of characters, it returns me a character. And in case you're working with an integer stack, we're going to return an integer. So I can take the help of top to get the top element of the stack, which I can print onto the screen. And after that, top will not remove the element. So I need to take the help of pop to remove that. Okay. Okay. So this particular code snippet will put in all the word program will be put in the stack, and then after that encountering space, it will try to pop out everything, and then it's going to print it. Let's see the output of this particular program and see if this does the entire task or do we need to do something more. So I'm just trying to run the entire program at one shot here. That is start execution program without debugging. And I could see here that yes, programming is printed in the reverse order. And you can also see that width is printed in the reverse order. But I could see some issues out here. What are the issues out here? There is no space between programming and width. That's first one. And the next one is the last word is not printed. Why is the last word not printed? Is the last word not inserted in the stack or not? Okay. So to understand that, we will try to debug this particular program. Okay. If you want to debug this program, you can just put a breakpoint, okay, at an appropriate place. Once you put a breakpoint, then, okay, you can just start traversing. So to debug, you can just click on the debug pull down menu. We can just say start debugging out here. So it's going to execute the first two lines. And after that, once it comes to the for loop, it stops. So you can just observe my data is programming Sikandar. I also have STK, and STK size is 0, meaning it is empty as of now. And I would like to also observe on C, the character C, what exactly it is. As of now, C is unknown because you're not entered the loop. So I would like to enter inside the loop out here. So I'll just use this option like step into. Okay, I'll just try to use this step into, or you can say step over any one of this. Okay, so you can just observe the C is having the data P out there. Is it a space? No, it's not a space. So if it is not a space, I would like to insert that into a stack. So you can just observe on inserting. Yeah, you can just observe the size in the stack is 1. And if you just want to know more about is it really inserted or not, you can just observe there's an allocator in that the first character is P out here. Fine. So you can just get into that and observe that. The same way I'd like to also do for the next characters. R, you can just observe size is 2. Then you can just see O, G, R, A, M, M, I, N, G. Okay. So you can just observe all the characters are put out here. And then after that, when you encounter a space, you just observe the character C is having a space. The ASCII value of space is 32. So if it is a space, what are we doing out here is we are popping out the elements. As we pop out the elements with the help of pop, elements will be deleted, but it will be deleting in the reverse order of insertion. So G was the last element to be deleted, and you can just observe G gets deleted. You can just see then the size of that keeps decrementing, and as we are removing the elements from this, we are also printing that onto the screen. Okay, here you can just see. And once the size of the stack is 0, it comes out of the loop, right? Okay. Now, do we terminate the program? No. So we had stopped at space. Okay, now we continue with the next character, which is W. So W is put out here. You can just see WITH, right? Again, when you encounter a space, you pop out and then keep printing it. After that, will it insert the third word or not? That's something what we need to observe. And on observation, you will observe that the last word is inserted. The last word is inserted. Sikandar is inserted. But after that, after the last character, which is R, you reach the end of the string. Once you reach the end of the string, you come out of the loop. So the last word which is there in the stack is not popped out. Okay, that's one major problem what we basically looked into it. So what we learned out now is the last word is inserted into a stack, but it was not printed. Okay, so just to make sure that we print the last word, so this particular code has to be repeated once outside the loop. Okay, this is for all the words except the last word, and this is for the last word. And one more thing what we also observed is the spaces are not inserted. Okay, like I'll just try to first run this and show you the output out here. Then we'll try to take care of the space portion out there. So you can just see now, yes, I could see that programming with Sikandar. Okay, it is reversing even the last word. Fine. But it is not printing a space. So what can I do it is, after popping out all the elements, I can print a space out here. This is one thing what I can do. Okay, so now I'll just try to run this and see if this is solving my problem. Yes, it is solving my problem, right? So the other way what we could have done it is, on encountering a space, we just did not insert the space in the stack. We just kept on popping out the elements. So what you can do it is, you can push even the space, and if you just pushed out space, then you do the job of popping it out. So here, what you can do it is, you need to even push out this space also. After that, if you just pushed a space, right? Remember, we can write if E space of C, go ahead and do this. Okay, go ahead and do this. And in that case, I don't require this. Yeah, this also has a small issue. I'll just show you out there. So you can just observe here at the beginning, there is a space, but between the last word and okay, the second last word, there's no space. Okay, yeah, it is good that if you can also work out with more data, which has more words. Programming with Sikandar is from Bengaluru, the city where I'm from. So you can just observe the problem is only the last word and second last word. So, okay, why is it? Because you first, on reaching out this space is pushed, and then, okay, from here you're printing it. So from space to programming is the first thing what you're printing, and this space to width is second thing what you're printing. This space to this particular, okay, S is the third one. So, but here, after reaching, okay, the last character, there is no space at the end. So for this special case, you have to take care of printing the C out here. So you have to write this particular thing here, because the space is not printed, right? But also remember, there's a space at the beginning. Fine, we need to look into that particular aspect. Fine, I hope the concept of this particular program is clear. Okay, I'll be sharing this particular code in the link section. Please do refer to it. Right. Thank you.